This is something that we've been making for quite a few years now. Always a bit of a pain in the arse to do whenever the order comes in, and we're doing less and less of them. But as you can see, it involves welding some parts together, a flat plate on the bottom as a base, and then a tubular piece and a channel section. It's to replace an obsolete part which was originally made from a casting. And every so often I think, well, maybe we should get some castings done. I don't know. Either way, I think they're not really worth doing. But I've just come across another problem with this. I've just welded this one up, and so if we can see, looking down that hole, the tube needs to be concentric to the hole, and that doesn't look like it is to me. And there's a reason why it's not, which is to do with tolerances on extrusions. This round piece is cut from a aluminium tube, nominally 7/8 OD, 1/8 wall, which gives a 5/8 bore. I've got an old one here, just fished out the drawer. 1.5 thou down on the OD. Couple of thou up on the bore. We do machine these out once they're put welded together, so that may not have come in that size, but current batch of tubes which I'm working with, seven and a half thou down on the OD, which doesn't really matter, but the bore 10, 11 thou up. So that is causing us a problem, because the way we put these together, I've got a spigot which goes in there and drops in the hole in the plate, and there's some other pieces. Well, I might as well put the rest of it together. So there's a little bit of a wiggle room there. There's a couple of packing pieces going here to centralise that. But this can move around. And that could be causing us a problem later on, because although we do remachine these once they're welded up, we run a reamer through the 1/2 inch hole there, and we also come down with a milling cutter in here and we locate off the reamed hole at the bottom. But if this is offset, I can envisage us having problems here. There's a stepped pin that goes in here, slides up and down, and it won't go in here until we ream out the hole in the bottom and remachine this bit on the top. But it needs to be a nice sliding fit, and if this is already oversized and offset, when we come to machine it, it's still going to be wrong, which might not be far enough out to matter, or it might cause problems. I don't know. I don't really want to risk it, so I think what I need to do is to make another one of these, which is a better fit on the tubes that we're working with at the moment. So this one, 5 thou down on the 1/2 inch hole, which is not too bad. That's a reasonable fit in the plate. That's not too bad. But 610, and the idea of the tube is 630, 631. That's 21, it's 0.5 millimeters of wiggle room here. I need to tighten that up, so I'm going to make another one of these. Bit of a pain. I was hoping to get on and crack on and weld these things up, but I don't want to have problems later on. It'd be not a good idea to have them all welded and then find that they don't work properly. So I'm going to make another one of these. And because we've just been making some other bits from brass, I'm going to make this new spigot out of brass as well. That should do us. $37 maybe off of there. Let's take 30 off and see how that gets to. Okay, 5 thou. Well, let's see if the tube will fit on there. No. It kind of does actually, because this is split. I think we're managing to compensate for the out of roundness which you typically get with an extrusion. I think that's a bit tight though. I don't really want it to be that tight. Probably another thou or two will be enough. Well, I probably could have taken that much off with some abrasive paper or cloth. 629. That is very nice. Yeah, slides on easy, but is a good fit. There's no rattle there, well, hardly any, so that's good. Let's do the spigot on the end. That should be good. Oh wow, ever so slightly tight. Ah, no, that's too tight. That's better. Yep. That should do just the job. I think so. Yeah. So, part that off. I'm getting really close to the shores of the chart. I should have pulled that blade out of there a little bit. It's not going to need much. Got a backstop in the collet inside this spindle, which is okay. That won't go back any further than that, but it doesn't need to. I'm going to leave that circle in there as a feature. Well, that's measuring pretty much the same. Oh, thou off. I'm calling that good. If I come up and touch on the 5/8 diameter, and then we need to come up 0.2. I think we'll do it in 2 goes. It's 0.1. I think we could go way faster in brass. So the only thing we need to do now is to put this little stop screw in the slot. Oh, this is annoying. Oh dear. Come on. Well, I suppose these split tubes are going to vary. If I made this a bit on the tight side, no, that's gonna. Well, if it's really tight, that might get stuck in there after I've welded it. Oh, hello, it looks like we've got a burr on the inside of the slot of the tube. Yeah, probably. Well, okay. We'll just have to see how we get on with this. I think that's there. Oh, squeaky brass. No, that needs to go deeper than that. Okay, 5/64 Allen key. And do you know what? That will do. That is fine, that's deep enough. So, is it going to do what I want it to do? If I'm lucky, it might help dissipate some of the heat. It's always a problem welding these things up because the plate is 1/4 inch, the wall thickness of the tube is only 1/8, or even a bit less in this case. So we always tend to burn this corner. Right. That bit there. Right, I'll just run this across belt sander. Ah, that's better. That is lots better. That looks fine. Well, only one way to really find out, and that's to weld one up and see what happens. Why aren't you going in there? Come on. That's it. Yeah, and I hope this might do a better job of acting as a heat sink as well. We shall see. Well, I don't know if you can see on the camera, I think this is better. I think we're getting the tube more concentric with the hole. Get a shadow in there, a bit hard to see for sure, but I think it's better. Only downside in, I had to knock the spigot out of the tube, so it might prove to be a bit of a blooming nuisance. But well, let's see. And downside to this process, of course, the various parts which do the job of locating the pieces for welding get blooming hot. Actually, that didn't sizzle, so maybe that's not so hot as it was when it was made out of steel. Okay.